Hello, my name is Jenna Stout, and today I am super excited to share with you my undergrad senior capstone, Design for Education. So I've just completed my undergrad, and I've been a student all of my life, whether that's been in university, the public education system, taking violin lessons, and so much more. But I've also been a teacher throughout my life. I've been a teacher in the form of a cabin leader at summer camp. I've been a teacher in the form of a violin instructor with group lessons and private lessons. And most important for my senior capstone, I have been a substitute teacher and also a summer school math interventionist teacher. Pictured here is my mom and I working in the classroom. These experiences have shaped who I am as a person, but also what I am passionate about. And I discovered some really unique problems during my time as a math interventionist teacher. So I'm going to walk you through the double diamond today, first telling you about the problem that I discovered, as well as how I defined it through research, interviews, and surveys, and then how I developed a solution to this problem, as well as my final deliverables for this capstone. So what exactly is the problem? Well, simply put, students are not good at math and they do not like math. After the COVID-19 pandemic, we found that students across the country lost 5 months of learning, and they have still not recovered to pre-pandemic proficiency, as you can see with these graphs. But this is true of all grade levels and, like I said, across the country. So with my skills in industrial design, I thought to myself how I could assist middle school and later elementary teachers and intervention students in teaching and learning core math concepts in the classroom. To really tackle this problem, I needed to focus on some key stakeholders, including the students, the teachers, and even the parents. Let's start with the students. I've used this term a couple times now, intervention, so I'll just tell you briefly what that means. Intervention basically refers to a student who is behind and not performing at grade level. So that's a 7th grader performing at a 6th grade math level, or even a 7th grader performing at a 5th grade math level. The different tiers of intervention tell you exactly how far behind the student is. Tier 1 is on grade level, Tier 2 intervention is about 6 months to a year behind, and Tier 3 intervention can even be 2 years behind. These students tend to be low-income minority students who struggle to learn online. But why target middle schoolers and later elementary students specifically? Well, to talk about that, let's talk about how students learn math. And this is a model that I found in my research. Students start by engaging with physical objects and concrete materials, and then transition to visual representations or pictures. Finally, students use symbols and number representations for abstract reasoning. As a designer, I wanted to focus on that very first step. What are these physical objects or concrete materials that we see in the classroom? Well, they're defined in 2 ways: digital resources and physical resources. We'll start with the digital resources. These are really good at what they do and include things like Khan Academy, IXL, Extra Math, so on and so forth. And what they accomplish is good, but digital resources are not good for every student or in every context. First of all, these resources result in increased distractions. Students are tempted to go on into a different browser and play games instead of doing their work. They also do not engage students in a meaningful way, as this is something they are very used to, and it's just not a very unique experience. It also results in an increase in cheating, as students would rather look up on ChatGPT or Google what the answer to their math problem is instead of trying to figure it out for themselves. And of course, the very nature of a digital resource means that there's going to be increased screen time, which is something that I wanted to get away from. So what are the existing physical resources right now? Well, there is a big focus on gamifying math, which isn't necessarily a bad thing, but not what I wanted to do, as taking the time to teach the rules of a game before learning core math concepts is something that isn't very appealing to teachers with only 50-minute class periods. Also, these are marketed towards younger students, meaning that they're about 1st grade through 4th grade, and they're not really meant for middle school students who are a bit older. As an interventionist teacher, I used algebra tiles, and I also looked at these other 3 materials, geoboards, number lines, and fraction blocks, to inspire what I wanted to design and improve upon. We are now going to start defining exactly who I am designing for. I wanted to split my user persona for the students into 2, starting with Aaron Rodriguez, who is a 6th grader, Tier 2 intervention student. He's super high energy and sociable, but he's also easily distracted. On the other end of the social spectrum, we have Catherine Anderson, a 7th grader, Tier 3 intervention. And she is very quiet and shy and self-conscious. She doesn't want people to look down on her because she isn't very good at math. And she's also on the autism spectrum. If we look at Aaron's typical day in school, we'll see that he comes in from recess and is super high energy. He enters his math class and it's his least favorite subject. But during work time, he surfs the web and his Chromebook and doodles on his worksheet. The math isn't engaging to him because he doesn't see how it applies to anything he needs to do in the real world. When he gets bored, he chats with his friends sitting next to him and distracts both of them from their work. This results in a very poor relationship with his teacher. When the test comes, he fails. If we look at Catherine's experience, on the other hand, she makes her way to the back of the classroom and doesn't really engage with the lesson. She looks over at her peers who don't seem to be struggling at all, and this dissuades her from raising her hand to ask for help. She tries to do the homework on her own, but she finds that it is very difficult. And because she is so quiet and isn't really making a lot of attention or drawing a lot of attention to herself, that means the teacher sometimes forgets her in the mix of so many students to keep track of. And so she ultimately fails her assignment when it comes time to take it. What about the parents? Well, this is another reason I wanted to cover middle schoolers. You see, parents feel very equipped to help their students with their primary education level math, but as the students get older, they feel very unequipped to do it. Things like algebraic expressions are just totally foreign to parents, and they haven't done that math in a long time. So they typically think to themselves, well, they can handle it. My 11 to 13-year-old, they're a preteen, they're about to even be in high school, so they shouldn't really need my help with homework. But this couldn't be further from the truth. We'll look at Mr. Grover, a parent who sympathizes with his daughter's struggles in math and wants to help her. He tries to help her with her homework, but he feels unequipped to handle this subject. And when his daughter tries to talk back to him, an argument ensues, and this means that the assignment is incomplete and they go to bed angry with one another. Finally, we'll look at the teachers. We often struggle with teacher shortages in the public education system, but especially post-COVID, teachers are more likely to quit. They're more likely to quit if they are younger, ages 25 to 34, if they work in low-income districts, and if they work in districts with more students of color. A new kind of teacher also emerged during this time, specifically post-COVID, with college students and veterans being hired on as a result of teacher shortages. And that is exactly the kind of teacher that I was. I wasn't necessarily equipped in the same way that my teacher peers were with a degree in education. My degree is in industrial design. But what do teachers think? Well, I surveyed 27 of them and interviewed a couple more, and this is what they had to say. First of all, the biggest problem was student engagement. It was very hard to engage students while in class. The hardest concept for students to learn was fractions. Speaking of fractions, 76% of teachers agreed that they want more non-computer resources. And finally, tactile tools, unique experiences, instruction, and partner work were found to be the best ways to engage students during in-class room time. So I would like to introduce you to Mrs. Moyer, a 5th grade teacher about to enter her math period with her students. She has about 50 minutes for this math period and 25 students. She spends the first 5 minutes of class quieting her students and setting up the lesson, and the next 20 are spent on the lesson itself. When the work time begins, she's walking around and redirecting students, and she's forced to spend more time correcting student behavior than actually helping the students who are struggling. And so at the end of the day, she feels defeated and exhausted. So what is the solution to all of this information? I am designing a physical kit of tools that will cover algebraic expressions, graphs, number sense, and fractions. These tools are meant to offer a unique experience to students, facilitate teacher instruction as students follow along during the instruction with their tools, and also offer a way for students to collaborate with one another. For this project, I collaborated with Kevin Dykema, the president of the National Council of Teachers of Mathematics, who is also a high school math teacher, Mike Clavin and Joe McKenzie, co-founders of Math Drawing Tools and work with Delta Math, and finally my mom, Rachel Stout, a Van Buren Tech Center math consultant as well as a middle school math teacher. So let's go ahead and start developing the solution. For the start of my capstone, I wanted to start by making a mood board, which would help establish the feelings that I wanted to invoke as students use this tool. It needed to be calm and soothing with primarily blue colors and soft edges, but it also needed to feel empowering. I incorporated red and black into my tools, and I will explain why later. But next, I entered my brainstorming. I did a lot of sketching for this project because that's how I think, and then I used my design guidelines to narrow exactly what I wanted to prototype. I knew that no matter what I was going to do, it needed to engage students, avoid screens, and avoid coddling. It needed to feel mature. But it also needed to be self-explanatory. It needed to account for paper space, and that just means it needed to fit on a student's desk alongside their worksheet. It needed to apply to the real world. Where do we see math in the real world, and why does it matter for students? How could I create something that looked like something that they would see at, maybe in their house? It also needed to work with existing curriculum. Teachers have a lot of curriculum to use. I don't want to write them a whole new set. It should incorporate into what they already have. Finally, it should encourage peer-on-peer collaboration and be low stakes and low risk. This means no fail states like in games. It should also transition students off the tool. These are training wheels, and they're not meant to use them forever. From here, I looked to real-world mechanisms and existing toys, whether or not they're math-based, and also real-world application, looking at places we do use things like fractions and number sense and coordinate grids. So then I entered prototyping, and I did so in two forms: foam core modeling and 3D printing. This taught me not only how I was overcomplicating some of these tools, I needed to simplify them and not over-design them, but it also showed me the dimensions of the tools and what would feel most comfortable in the hands of students and teachers for that matter. So I was able to test how I could interact with the tools that I was creating as well as the look and feel of these tools. From here, I chose some concepts, and these are the concepts here. The first two, the algebra tiles and organizer, as well as the graph tool, are meant to be derivative of existing products. And then the second two, the number sense tool and fraction tool, are extremely unique compared to competitors on the market currently. For this project, I also created a brand. I would really love to produce these someday, and I thought under the umbrella Bright Path Designs with the Edify Education line would be extremely fitting. The goal of this brand would be to engage children through meaningful tactile experiences, and the goal of the education line would be to inspire confidence and lifelong learning. So I would like to show you my deliverables for this project, Bright Path Designs Middle School Math Manipulatives. I will go through each of these tools individually, starting with the algebraic tiles, but here is an in-context render. So for the algebra tiles, they needed to focus on grouping like terms, solving algebraic expressions, and even covering number sense. I know this math looks scary, but do not be afraid, it is going to be okay with the algebra tiles. So what you do is, this is what a typical problem would be for a student in 7th or 8th grade. In this case, we are adding two equations together, so you would break it down based on each equation and then line them up. So if you have 3x squareds, then you get 3 of those tiles. How many negative x's do you have? 4? Well, then you get 4, so on and so forth. From here, because we are adding them together, we will link them up based on the pairs that they coincide with. And when they pair up, you take those pairs off of the desk, leaving you with your final solution, x squared plus negative 3x plus 1. As I worked with Mike Clavin and Joe McKenzie, who produce current algebra tiles, I found that it would be really good if there was actually a physical connection taking place with the algebra tiles, as well as the labels now being embossed for an additional tactile experience. The latching system only allows for x squared to pair with x squared. X can only pair with x, and 1 can only pair with 1. Additionally, I just created a simple box for this project as well, so that when students pair up the tools, they place them into the dividers, and they're labeled based on where they're supposed to go. And this just saves time for a teacher as they're asking these students to use these tools. It was a big problem for me as an interventionist teacher to ask students to use these when they had to spend the first 5 to 8 minutes reorganizing the tiles before they could actually build the problems. And the organizer just helps you to avoid that problem. So if we go back to Mr. Grover, who was really struggling with his child's preteen experience and doing this math, now with the algebra tiles, it reminds him of the rules that he couldn't remember beforehand, and his daughter is able to physically interact with the math while he explains it to her. And so they end up completing the assignment together. Next, let's go to the graph tool. This focuses on plotting points, teaching slope equations and rise over run, as well as the differences between the quadrants. So this is based on geoboards, which exist as a way to use rubber bands to build geometry, so hexagons and squares. So I took that basic premise and I've added a positive axis and a negative axis, also color-coded black and red. The purpose there being that is what we see in the real world, whether that be thermometers or even just in the language we use, like in business we'll say we're in the black or we're in the red to refer to if the money is going up or down. Included in this is also a point zero, which is neither black or red because zero is neither positive nor negative, so it is a neutral color. And the point plotter is meant to teach your students how to plot points. Sometimes students can do the math, but they start with the wrong points, so they still get the wrong answer, and this is a great way to teach them that lesson first. These are connected with snap fit connectors, which can withstand the tension of the rubber band against them, but also are easily enough removed for the building and rebuilding of the quadrant tools. So if you are a teacher and you start out with the positive quadrant, you can then add on your negative y axis and quadrant, and then add on the negative x-axis, and then finally add your fourth and final quadrant. This is unique from other math manipulatives in that you add on one quadrant at a time instead of going straight from 1 to 4. This helps intervention students to build on top of their previous learning. So from here you can use a rubber band to connect 2 points, in this case 1, 1 and 4, 4. You can also use the rubber band to build right triangles that represent the rise and run. So if you were to give a student the properties of a line, such as the y-intercept and slope, there are multiple correct answers here, so this is just one example of what a student might build. And you can even tell them to increase, quote-unquote, the slope, to double it. And this way they will see that it is the same line, which actually gets back to fractions. So there are multiple things you can teach here. If we go back to Catherine, who is learning graphs in her intervention classroom, now with the graph tool, she feels so much more prepared to approach this math. She sees that her peers and the teacher are using it during the lesson, and this encourages her to use it as it doesn't feel like she's being babied. This is just simply another tool, just like the Chromebook that she can use in class. So as she uses the tool, she is more easily recognized by her teacher, as her teacher can see exactly what she's doing right and wrong. And so next time on the assessment, she does extremely well. So now if we go to the number sense tool, this focuses on relating, I should explain what number sense is. That's basically just how positive and negative numbers interact, how -6 plus 10 becomes 4, so on and so forth. So it focuses on addition and subtraction, and also how double negatives work. This is an exploded view of the product. I really wanted to keep all of the small pieces here into one unit. So where the other ones have a couple different small pieces moving around, I didn't want anything to be lost here. I also have a view of the back shown, and this just shows some of the details that I included for an extra tactile experience. And we will jump into exactly how this works. The center marker moves on this vertical number line on these rails, and as you can see on these rails, there are ridges that hold the center marker in place. They also provide a little bit of physical tension as you move them up or down, as well as an auditory click that would sound reminding you of how many you've moved it. Let's do some easy math now. 5 minus 3. No matter what, you will always start at 0 facing up. In this case, we have a positive 5, so that means we're going to move up 5. When we encounter a negative, we flip it 180 degrees so that the arrow is facing down, and then finally end by taking it down 3, which brings us to 2. But what if we want to do a double negative? Well, that's easy enough as well. We will do the same process moving up 5, but this time when we encounter 2 negatives, you flip it a full 360. And so doing this tells the student that they are supposed to keep moving forward or keep moving up, and then they end up at 7. This is a more concrete building of this math concept than abstract reasoning. So for example, what I was taught in public education was to just draw a line down the middle between the 2 negatives. Now you have a giant plus sign, but that doesn't actually explain or demonstrate why that happens. So Aaron, who was learning number sense in his own classroom, now has the number sense tool to facilitate his learning. It's something unique and different. He hasn't seen this before. It's not like his school Chromebook. The only thing to interact with is the tool itself. And so when he talks with his friends, he now is interacting and working with them to do his assignment. And this results in a much more positive relationship with his teacher. And so the next time he takes his test, he does a lot better. Now let's do the fraction tool. Truthfully, this could have been its own project. I could have done my whole capstone on this. There's so much ground to cover with fractions, but I chose to narrow my focus to adding and subtracting fractions, simplifying and finding equivalents, as well as looking at the different written forms. Here is an exploded view of this product. Included is a base plate that connects 3 walls, in this case a labeled 8ths and 16ths wall, 4ths and 8ths wall, and 3rds and 6th wall. And then in the middle of this container will be stackable discs, and on each disk are 3 tabs, which we will talk about a little bit later. So let's say, as a teacher, you want your students to add together 1/6 plus 1/3. They will find that it is equal to 3/6, but they will also find that it is equal to 2/4 and 4/8. And when they stack up these 2 disks against the half cylinder, they will see it is equal to 1/2. There are so many learning opportunities here, not only for addition, but also seeing how these all simplify down to one form, as well as why they all equal each other. But what if you don't want your children relying on these labeled walls? That's not a problem. This kit would also come with unlabeled walls, teaching children to read them just like they would a beaker or a ruler. What if you want to simplify an even bigger fraction? That's included in this as well. On the top of each disk are 48 total outlines of circles. And so a different number, depending on how big the disk is or what value it represents, a different number will be completely debossed. So 8 out of 48 is 1/6, and it is on the 1/6 disk. 12 out of 48 is 1/4, and it is on the quarter disk. Remember those tabs I told you about? That's not only a great way to lift these disks out of the container, but it also has embossed labels covering the fraction, decimal, and percent equivalencies, and also exposing children to the different written forms of fractions. Here you can see a more in-depth shot of these being embossed. And if you don't want your students relying on these labels, that's also not a problem. You can flip the disc over to reveal a bright white sticker, which signifies to you and your student that they can no longer see the embossed labels. So if we go back to Mrs. Moyer, who was teaching fractions in her 5th grade classroom, she is able to do so much more easily now. The students, when they see something new on their desk, are immediately intrigued and head right to their desks, making the start time to class a lot faster than it originally was. And then during the lesson, they are able to follow along with her as she uses her fraction tool up at her desk. Then during work time, she is able to help students who are struggling being able to easily see what they are doing wrong, while the students who were originally problem children are now focused on their math with something new to engage them. And she feels a lot more accomplished at the end of the math period because of this. So to summarize everything I've told you today, I hope you can see how these tools offer a unique experience to children, facilitating teacher instruction, and even offering a unique chance for partner work. These tools are meant to engage students and inspire them to believe that they can be successful in what is often considered a difficult subject. Thank you so much to Kevin Dykema, to Mike Clavin, and Joe McKenzie for their assistance on this project, as well as to my class at the ICC and the ICC staff for their unwavering support. And finally, thank you to my family and my mom, without whom this project simply would not have been possible. And thank you for watching this presentation. It means a lot to me.